Hello friends, welcome to Mu Lessons. So today we will discuss on a very interesting topic. This video includes the equilibrium of concurrent and coplanar forces system, different types of system, supports, some numericals, and the most important thing is the triangles law, parallelograms law, and the Lamis theorem. So I have shown you a picture, so we will discuss, or throughout this video we will deal with such type of pictures, such type of diagrams, and we will find out what are the requirements according to our questions. So this diagram is just for an overview. Now moving to our video, first we will start with the definition. So if a system of force acting on a body keeps the body in the state of rest or in the state of uniform motion along a straight line, then this system of force is said to be in equilibrium. Or alternatively, you can say if the resultant of the force system is zero, then the force system is said to be in equilibrium. That means if the net resultant of total forces acting on a body gives a resultant to be zero, then we will say the body is in equilibrium. So we will study about all these types of bodies and systems. Now a coplanar concurrent force system will be in equilibrium only and only if it satisfies these two conditions. Remember, we are discussing about coplanar concurrent force. So for this type of systems, coplanar concurrent forces, these are the two equations or conditions which are need to be satisfied. That is, summation of fx, all the forces acting in the x-axis should be 0, and summation of all the forces acting in the y-axis should be 0. That is, the algebraic sum of the components of all the forces in the system along the two mutually perpendicular directions should be equal to 0. It is because we are discussing on the coplanar concurrent force. Now, what are the conditions for equilibrium? So it is given by the two laws, that is the triangle law or the polygon and the polygon law. So triangle law states that if three forces are in equilibrium, then they form a closed triangle which is represented in a tip to tail arrangement. You can see from these figures. This is just the triangle law. That means if the three forces are in equilibrium, then they are formed a closed triangle. Now this F1, F2 and F3 can be rearranged to form a closed triangle in a particular clockwise direction or anti-clockwise direction. Similarly, we have the polygon law. Triangle law is basically for three forces. Now if we extend the number of forces, then the polygon law comes into existence. That is, if the more number of forces or more than three number of forces are in equilibrium, then they will form a closed polygon that is represented in such a manner, that is tip to tail arrangement, and it can follow either a clockwise direction motion or an anti-clockwise direction. So this is a polygon's law. Now coming to the main topic, that is about the Lamis theorem. So what this Lamis theorem states, if a particle acted upon by three forces, so I need to make you tell you that this is only about three forces, remains in equilibrium, then each force acting on the particle bears some proportionality with the sense of the sine of the angle between the other two forces. That is, Lamis theorem is also known as law of sines. This is the most important thing you need to see. Now suppose this is at the middle point, this is the particle, and it is acted upon by three types of forces, F1, F2 and F3, and such that the system is in equilibrium. So out of this we can get the equations, that is, the forces acting on this particle will bear the same proportionality with the sine of the angle between them. So now here we have shown three angles, that is alpha, beta and gamma. So it goes like this, that is F1 by its opposite angle, that is sine alpha, sine of its opposite angle, F2 by sine beta, and similarly F3 by sine gamma. All these three should be equal. That means F1 by sine alpha is equals to F2 by sine beta is equals to F3 by sine gamma. Now there is an important thing to note, that while this Lamis theorem, all three forces should be either directed towards or all will be directed outwards, but it is never the mixture of both of them. Clear about Lamy's theorem? Now we'll proceed. Now before solving any type of problem, this is the main thing we need to remember, that is about the free body diagram. So what does this free body diagram states? That you have already read all these things in the second year of science, so just going as a review, it is an isolated diagram of the body being analyzed called a free body, in which body is shown freed from all the supports and contact, and instead of these supports and contact, the relative forces exerted by them on the free body is shown. So basically, in case of free body diagram, we have to remove it from all kind of supports and contact forces, and we will show the forces exerted by them in this manner. So you can see this ball, this round structure. Suppose this ball is attached to a wall, then this wall gives a reaction Rw, and suppose it is attached to a tension, then cable or a string, then the tension is given in this manner. The weight acts downwards, and P is the force that is given in this manner to hold it towards the wall. Now there is one thing important to note in this case, that is this free body diagram should be very neatly drawn, sufficiently big, so that you can analyze it very easily. And once you complete your analysis with this free body diagram, then the numericals become very easy to solve. Now few guidelines for drawing FBD, that is about the tensile force. It is the force trying to pull or extend the body. It is represented by a vector directed away from the body. Another force is the compressive force. It is the force trying to push or contract the body. It is represented by a vector directed towards the body. The reaction at the smooth surfaces, that is the reaction of smooth surfaces like walls, floors, inclined planes, etc., will be normally to the surface of the pointing towards the body. Another is the force in link orders, that is connecting the rods. These forces will be acting along the axis of the rod towards or away from the body. They can be either compressive or tensile. The forces in the cables, if you attach a string or cords like that, then there can be only tensile forces in that case. Thus these forces will be along the cable and directed away from the body always. Tensions in the cable on either side of the smooth pulley will be equal in magnitude. Now if you will face such type of problems, then you can see if this is the pulley and these are the two cables attached to the two sides of the pulley of a smooth pulley, frictionless pulley, then they will experience same amount of force. Now coming to the principle of transmissibility. So according to this law, the state of rest of motion of the rigid body is unaltered if a force acting on the body is replaced by another force acting on the same line of action. Suppose this force is acting at this point and it has got a line of action as shown. Now suppose if you transmit or transfer this force somewhat little downwards, still then it will act on the same line of action. Then this can be said as equivalent. And there can be no change in this type of figures. That means in this case F and this case F dash, these both are equivalent forces. So condition of equilibrium for motions are not affected by transmitting a force along the line of action, and hence both the forces are same or equivalent. Now I have already told there are two laws, parallelogram law, so I will just go as a review because already you have read all these things in a +2 level. According to this law, the state of rest of motion of the rigid body is unaltered if the force acting on the body is replaced by another force of the same magnitude and direction but acting anywhere on the body along the line of action and can be replaced by that force. So that is the parallelogram law. Similarly, we have the triangles law, that is if two forces acting on the body are represented one after another by the sides of a triangle, the resultant is represented by the closing side of the triangle taken in the opposite direction or from the first point to the last point. Now this is a simple example. So we need to calculate the moment at the position B. You can see from the picture, this pictures and solutions has been collected from net. You can also find them out. Just for the sake that you can easily solve some questions, I have put together all of them here, so at least I can help you in this manner. So here we have two rigid supports, that is A and B. Now we need to calculate the moment at B. So what are the given things is the dimensions, that is the length, the distance between the two moments, the distance between the center of gravity from these hinges, and a weight of 2400 kg is hung in this part. So the distance of this weight from the center of gravity, all these things are given. Now for the moment we need a force and a direction. So as this system is not moving, you can see, so the net force at point A should be 0, obviously. So for point A we need two forces, we need a force and with the direction. So let that force be Bx into 1.5, that is the distance, minus 9.81 into 2, that is acting along the center of gravity, then minus 23.5 into 6. Similarly, you can find the moment of forces for a number of systems given in this picture or in some other pictures. Also in this case, summation of forces along the x-axis is 0, so we make it as ax plus by equals to 0, and also forces along the y-axis should be 0, so we make a equation of ay minus 9.81 minus 23.5 equals 0, so that brings ay equals to 33.9 kilonewton. Now our main aim was to find the moment at point B. Again we write the equation for summation of all the moments at point B, and we put all the values and we get it as 0. So this shows that the moment at point A and point B is 0, and hence it is an equilibrium system or equilibrium of rigid body. Similarly, from this figure, this is a roller hinge and this is a fixed hinge. The value of this P is given as 15 kilonewton. Now in this case also, summation of all the forces and moments along x and y direction will be 0. So Fx is 0 as it is lying on a horizontal plane. No force is along the x direction. Similarly, Bx is 0. For moment at A, point A, we have minus 15 into 3. You can see from these equations, that is P value is 15 into 3, that is the distance between the application of force of P and A. Similarly, we put the values of all the other things, by into 9 minus this and this, and that comes up, that has to be equal to 0. So from this equation we get by equals to 21 kilonewton. So as this is positive, it is acting upward direction. We have got Py that is acting in upward direction. Similarly, we have to calculate the net moment at point B to be 0. We get A equals to 6 kilonewton, and that is also in upward direction. Now we need to check the summation of all the forces along y-axis is 0 or not. Now by putting all the values as a summation of forces in all the y direction, and that comes out to be 0. So this also says that it is an equilibrium system. Now for this equilibrium system, the main thing is summation of all the forces in both the axes should be 0, and the moments will also be 0. So you can proceed in the reverse manner also to get other kinds of variables if it is given in this question. Now there are different types of supports, like simple support, roller support or hinge support. Now in case of simple support, if one end of the beam rests on a fixed support, the support is known as a simple support. And in this case, if one end of the beam is supported on a roller, then it is roll support. And for the third type, if the beam does not move either along the normal of the axis but it can rotate, then it is called as hinge support. There is another type of support, that is the fixed support. In this case, the beam is not free to rotate or slide. That means it cannot make any translational motion or rotational motion along the length of the beam or in the direction normal to the beam. Therefore, three actions components can be observed in this case. It is also known as built-in support. Now these are some pictures, just in the previous slide you have seen. This is a simple support, just keeping on simple support. These are some kind of roller support in which they can move, or the beam is attached to the roller side. This roller support can be of various types, on horizontal plane, or it can be on inclined plane, or it can be guided roller. By guided roller means the roller is in between the two obstacles. Similarly, we have a hinge support or fixed support or built-in support. Now the main thing is not analyzing this diagram, the main thing is to draw the FBD for these types of diagram. Now in this case, if you want to draw the forces, then this V will be upwards, that is a vertical force, horizontal force will be perpendicular to this, and as a result we will get the resultant force. The most important thing in this case is drawing the resultant force and showing all the reactions and net forces acting on this diagram. That means we have to be clear about the free body diagram before coming into these types of problems. We have also various types of beams, like the simply supported beam, fixed beam, overhanging beam, cantilever, continuous beam. So this will discuss when we will come across such type of problems. These are some examples of the beams. In this case also, the main thing is to calculate the moment, to get the normal reactions, and to resolve all the forces to get the answers. So that is the main aim. Now suppose we have to find the reaction on the support for the beam as shown in this figure. This is the first figure. You can see A and B are two hinges. This is a fixed hinge, this is a rolling hinge. Now you need to find the reaction of the supports in this case. So what will be the reaction in this kind of supports? So first of all, the first and foremost thing is to draw a free body diagram. So I have taken all these things, pictures and all, from internet. So collectively I can show you all these things, so you will not be harassed searching in internet. Now after drawing the free body diagram, that becomes quite easy. Now as this is a rigid support or a hinge type, in this case we have two forces, that is horizontal and vertical, as I have told you before. And in case of roller type, we have only the roller reaction. Similarly, a force 100 kN is given in this direction, so it can be resolved in two forces. Now after drawing this free body diagram, next comes the problem solving technique. In this case, first of all we will start by using summation of FH, that is in the horizontal direction or x-axis, we have to get 0. As the system is in equilibrium, summation of all the forces in h direction will be 0. Now making an equation, or you need to calculate an equation in the h direction or the horizontal direction. So we get the HA to be 60 kN. Now as we have used a roller hinge or a roller support, then it is also not moving, that means the moment at that point B is 0, so summation of the moments at B will be 0. So we calculate the moments in that case, and that gives the vertical forces VA, that is equals to 68 kN. And finally all the vertical forces should also be 0. Then by calculating we get the VB equals to 72 kN. Now in the previous diagram we have three forces to calculate, that is HA, VB and VA. So all these are calculated as from the solution part. You can just write it down in a copy and you can analyze them. Now coming to the Varignon's theorem, the moment about a given point O of the resultant of several concurrent forces is equal to the sum of the moments of the various moment about same point. That is, it makes possible to direct determination of the force or the moment of force F by moment of two or more forces of the forces F. Now if this particle is experiencing several types of forces in several directions, then we can have the summation of all the moments and we can resolve them to get a summation of one moment, that is R into F1 plus F2 plus F3 and Fn. Similarly, the moment of force about a point or axis measures the tendency of the force to cause the body to rotate about the point or axis. Now this moment is given as force into the distance. Now suppose when you are opening a door, that is also about a force into distance. Now you can't open the door at the hinge by pressing at the hinge, so you need to give your force a little bit distance from the hinge. So that is what the concept of moment. You can better tell it as torque also. Similarly, we have a moment of couple, that is, a couple is defined as two forces or parallel forces that have the same magnitude and opposite direction and are separated by perpendicular distance t. Since the resultant force of the force coming to the couple is 0, the only effect of the couple is to produce a rotational and tendency of rotation in a specified direction. So the main aim of this moment of couple is to provide a rotational direction. So this was an overview about the equilibrium systems, and I have also given a question set with this so you can practice them. Thank you.